Hello friends. So let us start with the problems on friction blocks on horizontal surface. So today's topic will be related to horizontal surface blocks which are acting on the friction. First problem, a body weighing 100 Newton is resting on a rough horizontal surface. If a horizontal force of 30 Newton is just sufficient to push the body, determine the coefficient of friction at the surface of contact. Solution starts with first one, draw the figure as per question. So let us draw the figure as per the question showing a horizontal surface on which a body weighing 100 Newton is resting. So weight we are representing with W, horizontal force of P. So let us draw the free body diagram for this particular figure. So the free body diagram for the above figure is like this. So weight is acting downwards, horizontal force is acting P. Normal reaction from the horizontal surface is N, and for the P horizontal force, opposite frictional force is F. F equals to mu into N. So now considering these free body diagram, we are going to resolve the forces into X and Y direction. Summation F of Y equals to 0 minus W acting downward considering minus, acting upward considering plus. So minus W plus N equals to 0, minus 100 equals to minus N. N equals to 100 Newton. So let us consider this as equation number 1. Summation F of X equals to 0, P minus F equals to 0. P equals to F. So P is given as 30 Newtons equals to mu into N. 30 equals to mu into N value is 100 from equation number 1. Now we have coefficient of friction from this part, mu equals to 30 divided by 100. Therefore mu equals to 0.3. So also we know that mu is equals to F divided by N. So using that equation we are able to see that mu equals to 0.3. To next question, determine the value of P required to slide the block B in the arrangement shown in figure. Also determine the tension in the string. Take W equals to 500 Newton, WB equals to 1000 Newton, mu equals to 0.2 for all contact surfaces. So this is the figure wherein we are having block A over a block B. This is horizontal force P. Here the string is with horizontal surface or horizontal line 30 degrees inclination. So now for solution part, first we will consider solution. Let T be tension in the string. Consider the free body diagram of block A. Resolving the forces in x and y axis, summation f of x equals to 0, t cos 30 minus fa. So the free body diagram is on this side. You can see the free body diagram wherein considering the free body diagram of block A is weight of WA is acting downward. Reaction from the block B, normal reaction NA we are considering for block A acting upwards, and this is the tension in the string which will try to move the body in the right side direction. This body will try to move in the right side direction. When the body is trying to move in the right side direction, we are able to get the friction in the opposite direction. So therefore the friction is represented as Fa equals to mu into Na. So this is horizontally for the motion trending opposite in direction. Now resolving this t in x direction as t cos 30, resolving this t in y direction as t sin 30. So same forces we are considering in resolution of forces in x and y axis. Summation f of x equals to 0, t cos 30 minus fa equals to 0, t cos 30 minus 0.2 Na, 0.2 mu equals to 0.2 equals to 0. Na equals to 4.33 t. T cos 30 minus 0.2 Na equals to, so Na equals to 4.33 T, equation number 1. Now resolving the forces in y direction, we are writing the forces in y axis. So we are having T sine 30 plus Na minus Wa, because it is acting downwards, considering it as minus. T sine 30 plus 4.33 T, value of Na from equation 1, minus 500 equals to 0. 0.5 T plus 4.33 T equals to 500. T 4.83 equals to 500. T equals to 500 divided by 4.83. T equals to 103.52 newtons. Na equals to 448.24 newtons. So moving to that, we are considering the free body diagram of a block B. The block B free body diagram is like this, wherein the P is acting horizontally with respect to the block, and block will have a friction opposite to P direction. So WB acting downwards, Na acting downwards, NB acting upwards. Writing the equations along equilibrium, summation f of y equals to 0, minus Na minus WB plus NB equals to 0, minus 448.24 minus 1000 plus NB equals to 0. NB equals to 1448.24 newtons. Now writing the equations along x direction. So FA value we are having 0.02, 2 into Na, and FB value also we are having 0.2 into NB. NB value we are knowing, Na value is also known. Writing the equation in x direction, minus P plus mu into Na plus mu into NB equals to 0, minus P plus 0.2, 4.448.24 plus zero point 0.2 into NB value equals to 0. Therefore, we are having the horizontal force P value as 379.3 newtons. Let's move to the problem number 3. A block weighing 2000 Newton is attached to one end of a cord which passes around a frictionless pulley as shown. Carries a load of 800 Newton at other end. Find the value of P if the motion is impending towards left, if the motion is impending towards right. So here is the figure shown in the question. This is the cord which is coming around the frictionless pulley, which is having a weight of 800 Newton, and the angle of this with respect to 2000 Newton block is 30 degrees. So solution, let T be the tension in the string. Considering free body diagram of 800 Newton weight, this is 800 Newton weight, 800 is acting downwards, T is acting upwards. Summation f of y equals to 0, minus 800 plus T equals to 0, T equals to 800 Newtons. Motion impending towards left. So first condition we are considering when the body is trying to move in the left side direction. So this is the free body diagram. Going to next particular. So coming to motion impending towards left. So this is the free body diagram of a block. W is acting downwards and the reaction is acting upwards, N1. So motion trending is towards left. So for this motion trending, friction is acting opposite. F1 is equals to mu into N1. N1 we are considering for first condition, F1 is considering with respect to the first condition. So this is the tension T which is resolved in y direction, resolved in x direction. Writing the equation along y axis, minus 2000 plus 800 sine of 30 plus N1 equals to 0. So we are able to find N1 equals to 1600 newtons. Now writing the values along x direction, minus P plus 800 cos 30 plus F1 equals to 0. Minus P plus 800 cos 30 plus 0.35 into 1600 equals to 0. Therefore, In first condition, we are going to get the value of P is equals to 1252.82 newtons. Now moving to second condition, motion impending towards right. So body is trying to move in the rightward direction. For this, friction is acting in the opposite direction. So here we are considering N2 as second condition, F2 as corresponding second condition. W remains the same, acting downwards, which is 2000. Now what will be the P value we have to determine? So here the tension is acting, which is again 800 newtons. So T is in Y direction, T is in X direction. Summation F of Y equals to 0, similarly as the earlier one. So we are able to find N2 as 1600 Newton itself only. Now summation F of X equals to 0 minus P plus 800 cos 30 plus F2 is equals to 0 minus P plus 800 cos 30 plus 0.35 into 1600 is equals to 0. Therefore, P value is equals to 132.82 newtons is the value of P. So this part of weight is here, which we can see W is equals to 50 plus 86.9, and in this we are able to write those equations. 86.6 divided by mu plus 50 equals to 103.36 divided by mu minus 37.62. Now taking all on one side common thing and on the opposite side the common thing, we are able to get that mu is equals to 16.76 divided by 87.62 and mu value is equals to 0.19. This is the mu value. Substituting this mu into the equation 2, we are able to get the weight of 506.38 newtons. For a check same value of mu, we can substitute in the equation number 1. We are getting the weight of W as 505.78. Using this mu value, we are also able to find the value of N2, F2, N1 and F1. So friends, similar problems are going to come into the friction chapter. So you can expect some more problems related to the friction on horizontal blocks. Also try to make good likes, shares and subscription for the channel so that you are going to get some more interesting problems depending upon the different topics of engineering mechanics. Thank you for the day and also good night.